Hello, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to come onto the stream to show off your project, you can find the link in the live broadcast chat in our Discord. That's at adafruit.it/Discord. First, though, we're going to kick things off with folks at Adafruit, and let's hear from Melissa. Hey, Melissa,
Hello.
how's it going? Good.
It's going well. I just got back from Open Source this last weekend, and anyway, so today I decided to try out welding for the first time.
All right.
And so I just kind of wanted to show that off here.
Yeah.
It's just a little.
Cool.
I welded a nut to the inside of this, and then I welded the metal onto here. So
nice. It looks nice and smooth.
Yeah, I ground it down with an angle grinder.
Cool. And is that I don't know much about welding. Is that MIG and TIG? Are those the two types?
This one I did flex core welding. It's basically like MIG, but instead of gas, you have flex built into the wire itself.
Okay, very cool. And so I always see folks on YouTube, they usually have like a woodworking background when they do welding. So I'm curious with the electronics background, did you find it similar to soldering? Like, did you think the skills were transferable or?
Not so much.
Okay.
I mean, you're wearing a welding helmet, which is darkened, and then
Fair.
You're just trying to kind of get all the settings just right, and then get the feeding and the voltage and the amperage and everything so that it's you're able to maintain a weld bead. So
cool.
So it was definitely challenging because my welder didn't come with any directions on like the settings or anything, so I had to kind of figure that all out.
Well then, excellent job then.
Oh, thanks.
Yeah, that's cool. So I'm looking forward to seeing if you continue it, see what you make.
Yeah, this is actually just going to be a reinforcement for a shelf that I was making.
Nice. Awesome. Well, thanks so much, Melissa. Cool. All right. Thanks. And next we're going to hear from Scott.
Hey, Scott, hello. How's it going? Hi, Liz. Thanks for running show and tell.
No problem.
I've been not doing a lot of Adafruit stuff because Ari, my son, had an ear infection and I'm sick, and he just went to daycare and got everything. So I'll show something that's not Adafruit. I just got it in the mail. It's something I've been like keeping my eye on, but it's this board. It's the ORBTRACE-MINI. You can see there, and there's this project called ORBTRACE-MINI, or I'm saying it wrong, I'm sure, but it's all open source trace capture. So these high-end Cortex M7s, like this is an ST board. But the IMX RT10 series is also an M7. They have, and a lot of other M's as well, have this trace port. And it allows you to capture every time the code jumps. And that allows you to basically know exactly where the code ran completely, which is pretty neat and pretty nice. It's great for debugging. Like if you just kept like the last buffer, you'd be able to say like, okay, what just happened, right? Like I just crashed. What happened before it would be really nice. And then the other thing that I'm curious about is a thing called performance guided optimization. Basically, you say, okay, compiler, take into account which parts of this code previously was like used a lot or not, and try to optimize for these particular patterns and stuff. So that's kind of neat as well. And so I picked up this board. It's actually an FPGA, which is cool. And it's got all open tooling and it's all open source, which is great. So I'm gonna play around with that at some point in the future. But I was happy to see that they're in stock and I snagged one.
Excellent. All right. Well, looking forward to seeing what you do with that.
Thanks, Liz.
All right. Have a good one. Next, we are going to hear from Jeff.
Hi there.
Hello.
So Lamar was kind enough to send me a prototype of the Metro RP2040, which it'll be a fun little board because it's got the Arduino headers and all that stuff, but it's got the power of the RP2040 that we like. And it has a micro SD card slot. And you may know that there are two major ways of talking to an SD card. One of them is called SPI, which we use with more peripherals other than that, like displays. And one of them is called SDIO.
Yes.
And so what Lamar tasked me with doing is making sure that the board setup worked with SDIO, which we hadn't done with RP2040 before. Cool. And Raspberry Pi they've got this repo called Pico Extras, which is code that's not quite ready for like general use. But I took their example of SDIO and adapted it so it can work in CircuitPython. And so if you bring up my screen, I'm just going to run a small benchmark. Now, keep in mind that that this isn't optimized or anything, but let's see. First, we're going to test with SDIO-IO, and my test failed. So let's run that again. I'm just power cycling the board here. Hopefully, we get a different outcome. But yeah, so each dot is reading 512 bytes. This is actually the text of Moby Dick. So with SDIO-IO, the new way, we were reading at 422 kilobytes per second. And because the card can't really change modes, you have to pop it out and pop it back in if you change mode. So it's like powering it off and back on. Very cool. And I'll hit enter again. And I mean, the dots still come reasonably fast, but at the end, we're going to be at just 264 kilobytes per second. So it potentially provides a faster way of accessing SD cards. And you'll be able to use whichever one is right for your application, because I think, like, for instance, the pins are actually shared with the SPI pins, so it might interfere with the display or something if you wanted to use them both. So for your project, you'll have to make a choice, but it's great to know that we've got that option, and this board will be coming soon once the rest of the kinks are worked out. So that's awesome. What I got to tell you tonight.
Great. That's awesome. An excellent visualization of this optimization you put in. Cool. Thanks so much, Jeff.
All right. Have a good one.
Thanks, you too. All right. And now I think we're going to have JP play us out. I don't see any folks from the community. So last call if you want to join in. Hey, JP,
hey, how's it going, Liz? Good. I actually, I have two demos, both sound demos. So I was getting something set up that I'm excited to show. And then my buddy Toddbot said, hey, you showing that cool Blade Runner synth thing since you just finished the Learn guide? I was like, oh yeah, this might be a good time to show it off in its final form. So I ran, got it set up. So I think we're good to go. What I'll do is if you can show my shared screen.
Yes.
This is it. So this is the Tyrell Building. It's a model I built to look like a sort of simplified version of the Tyrell Building from Blade Runner, which is the big, huge, evil corporation. And I've seen people say before it's, I don't know, like 8,000 stories high if you do the math of the size of the thing. It's just like bigger than any science fiction building is this Tyrell city almost inside of a building. Mine's much smaller. Fits on a pretty modest 3D printer. And what I've done with it is on the inside, I've got, I won't pull it all apart right now, but I've got on the base here a little base that pops in, and these two center screws are where I have a little PermaProto board, quarter-size PermaProto hooked up, and it has a little Cutie Pie and an audio jack. It's doing all of its audio actually in PWM. And this is using CircuitPython's Synth.io library with a cool bit of code that Toddbot had written called 80s Dystopia. And I just added some features to it so that I could modulate some stuff, some of the notes, the speed in which it changes notes, the frequency of this little filter oscillation going on, and the volume. So I'm entering any of those commands with these little sort of pairs of these pillars by touching this cap touch copper tape. So what I'm going to do is turn the volume up on here. And let me know, is that a good, can you hear me? Yeah. Okay, great. So in its pure form, it's just this cool sort of set of, I think, 6 or 5 detuned oscillators. So they're all just moving and swirling and wubbing and stuff, which is cool on its own. You also notice every few seconds the note changes that the base of this whole chord is built on. It'll adjust itself maybe every 10 seconds or so.
That's cool.
So one of the things I gave it was the ability to increase or decrease the rate at which it changes notes. So I'm going to decrease that.
Okay.
So now it's going through these set of 4 notes. It's just got this little list of notes.
Yeah.
Actually 3 notes and 1 that's an octave.
Okay.
But what I can do is if I get bored of that, I can take the whole thing and transpose it. So I've got a second list of notes that'll just transpose the whole thing.
Sweet.
So now we've kind of modulated.
Yeah.
And I can go back. I can play that almost like it's notes. And again, keep in mind, this is all happening just in Synth.io.
Right, yeah.
Inside of CircuitPython, which is mind-blowing that we have this working.
It's so powerful. Like, it's
incredible.
Really,
it's fun to use. It's all just a saw wave, but like a mass of them that are detuned a little bit from each other, and that detuning changes. Another thing you'll notice, I'm going to slow down the, or actually rather increase the interval time. So now it'll hang out on notes a lot longer. These two plinths here, or whatever we call them, will set. I decided rather than ticking through some different speeds, I just have either normal or real fast for that filter oscillation. So when I go to real fast,
oh yeah, here.
You get this wow, 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 but that also has some randomization applied to it. So it's nice, and I can listen to this for hours, and I have while I've been working on it because I just love this kind of stuff happening in the background.
Yeah.
We can go back.
Dystopian synths to relax to.
It's so dystopian. If I tap this one, I go back to the more moderate filter modulation, so it's not going crazy. And then this one here is the volume, so I can increase or decrease. And be done with. Then that it sort of serves as the off button. So that is a Learn guide that's out now. You can go check that out. You can print off a little model if you want. You can modify it wildly. You can say, I just want alligator clips and pennies hanging off of a cutie pie, and do it that way. It's up to you.
Cool.
So that's the Tyrell Building as synthesizer.
That came out great. I love how responsive too that the cap touches. Like,
yeah, it's actually, now that I'm done playing it, I'll pop it open. So I have screws that I threaded and everything, and decided not to use because it just pops off easy enough without it.
Fair.
So there you'll see the juicy innards.
Yes.
You'll see a bunch of resistors here, and these are used, anything over like a mega ohm resistor is what you'll use to use the cap touch.
Right.
So every pin, I have 8 of them, will have one of these little resistors going to ground, and then a wire. I know it's a little hard to see in there. There we go. A little wire per 8 pins running to my copper tape up in there. And I modeled some little holes that allow those wires to run out to their capped touch. You could cover this. So that's one of the nice things about capacitive touch is it's not resistive touch. You're not grounding it. You don't need to be part of the circuit. You're more of an antenna. So you could reface this with something, paint it, fabric, who knows, embed it in your print somehow. There's ways you could avoid doing just this shiny copper. But I know this will tarnish over time a little bit too. So it'll probably kind of look nice and worn. So that is that. That's that guy. I'm happy with the way this came out. And one of the key things, since I didn't want to make it too big, is using some little right angle connectors for USB and audio jack. Makes life a little easier.
Handy. Yeah.
So snaps back together. I'll put that off to the side. So then the other thing, do we have time, or should I?
Yes, we do.
No time. Okay. Since we have time, I wanted to show off a pretty cool estate sale find I got a while back that I don't think I had ever shown on any of my shows. So you're looking at it in its weird bare state right here. And it is a 1987 drum machine from Korg called the DDD-5.
Nice.
Which was the successor but less professional version of their DDD-1. So I think the DDD-1 is more desirable, but this one is a little newer. And the reason it looks so weird is that it had this excellent feature of removable faceplates depending on the mode you were using it in.
That's very cool.
And I only have the one. There was a second one which would have come with it. This is programmable mode. And so it doesn't change anything about the functionality of the drum machine. It just changes your cheat sheet, basically. So you can use the buttons in the 2 main modes, programmable or preset mode, but you were supposed to swap these out when it was time to click these into place here. when it was time to switch modes. And then there were also, I believe, a few others, maybe 2 or 3 others that came with add-on cartridges. And I have a few of these cartridges, which are pretty cool. This is essentially a sample playing drum machine with velocity sensitive triggers, which are really nice. They're some of the nicest I've ever played with. But you could get these little add-ons like, I need some more cymbals, or even more cymbals, or drums, or bass drum. There's even one that's got, and I haven't played with this one yet. I'm dying to, because this is really the sound of 1987, is gated reverb. It was a type of reverb.
Nice.
Prince used the heck out of it, but so did everyone else in that era. So this has some bass, snare, hi-hat, and mid-toms that have this particular type of reverb applied to them. So you'd pop these cartridges in, and that gave you, I think, 16 extra voices. So on its own, it'll play any of these 8 pads, and then there's 2 rows of them that you can switch between.
Okay.
I'm going to plug this in so you can hear some audio coming from it. And let me turn that down. There.
You always have the greatest estate sale and sidewalk.
Oh man, I tell you, there's always a few that get away for the ones that you see. I missed one the other day that was this is like 2 days ago. I saw something up on like a local Facebook. Hey, this is on the curb, and I drove there and it was already gone. It was a Yamaha FM sort of stage piano synth from about 83 or so. You know, not worth tons and tons or anything. And geez, I have enough synthesizers, but you're kind of like, oh man, I hope whoever got it like uses it and loves it and cherishes it, because it's nice if people keep them out of the dump. So this thing is right now actually not in the mode that you see here. I've got this in preset mode, so it's ready to play songs. It can play combos. You can arrange patterns, so you can have intros and rhythms and fills and outros and so on. So I think if I just hit start here, there's a chance. What have I broken? Here we go.
There we go.
So this is some built-in R&B pattern. You can play on top of that. And then you can also get out of these pattern modes and change the operation entirely. So this is why this whole thing matters. If I want to try to get out of this mode, I'm going to hold essentially an X and a Y key. It's like a matrix of stuff. So I just told it operation. That's what I want to hit, and now up here on the display, it's saying, "Do you want to change the operation?" And I'll hit this yes button. Now you can just more play the. And it's also got a flam on it, which is like a little double off time stick hit, which is cool on snares. And it has rolls, which sound really good on stuff like claps.
Excellent.
And then that's the preset set of, I think, maybe all the sounds that come on it. I'm not sure if it has a second bank. And then swapping those are what all these crazy little cartridges are for. And there was one other in here that's some sort of a DIY cart that just says memory card, 128 kilobits of RAM.
Okay.
And it had even a little replacement battery on it. So
that's cool.
Wild. I know so little about this that I shouldn't even be showing it off, but I was excited. So that's the DDD5 drum machine, and the very, very little I know about how you use it.
Excellent. Well, thank you so much for giving us a tour.
Sure thing. Thanks, Liz.
Thanks. All right. And now we have one person from the community that just joined, YSPACE Labs. Hey, how are you?
Okay, yeah, just... good. Can you hear me?
Yeah, I can hear you.
Okay. Okay, great. This is working.
So, what are you showing today?
Oh, wow. Okay, yeah, it's really delayed, so... this is a hot plate.
Okay. And is this a hot plate that you're modding, or did you design yourself, or?
Okay, so actually starting now. So this is a hot plate that I designed myself.
Very
So
cool.
um, oh wait. Okay. Finally got it all figured out. YouTube
Cool.
was in the background running.
Oh, okay.
So
Yeah, no worries.
I designed this myself. So custom PCB, powered by an RP2040 running
Excellent.
CircuitPython.
Oh, great.
And so things. And one of the interesting things about this one is that instead of having a temperature sensor that's on the board, that's on the hot plate itself, it uses the resistance as it changes the positive temperature coefficient to measure the temperature, and it's surprisingly accurate. So the this INA 237 right there measures the current going through this shunt resistor to the hot plate, which is turned on and off by this MOSFET. And so if I attach everything, it's designed to work off USB PD, but I haven't got that working since it's hard to debug off this because I can't debug off the same port that I'm powering it with.
Yeah.
And, so if this, I just moved my bench power supply up here, and I need to get it up to 20 volts, where it's able to heat up. And I'm using this instead of a small one like this. It turns out that these CNC buck boost converters you can get on Amazon are extremely noisy and have garbage load regulation. So the temperature reading just like goes up to 100 and then down again, and it has no idea what it's reading, even though but this is able to keep it stable, probably due to the bigger output capacitors.
Sweet.
Okay, and yeah, so I built up this interface. It's half working right now, but it works well enough that I can use it in most applications. So I can set it up to 170 degrees.
Cool.
And it should, and press the button, and okay, wait, okay. Actually, I think an issue is that I set the current limit on the power supply too low. Okay, there we go.
Oh, great.
Okay, and there it's going.
Excellent.
Yeah, now it heats up pretty quickly since it's drawing about 50 watts, which then just drops down to so now it's at about 45 watts, heating up to 70 degrees Celsius, and I verified that this is actually pretty accurate. It is able to, like, the ability to reflow boards is kind of minimal. I don't really have a board, but I might be able to get a pipette with some water.
And do you have the files for this up if folks wanted to see your design or code?
I can post them on GitHub.
Okay.
I just haven't yet. It's kind of incomplete, but
Fair,
I guess but it works right now, and it's at a level of completion that is able to, I guess, be okay.
Awesome. Yeah. Well, as you continue to work on it, definitely come back, show us your progress, and drop your files in Discord to share with the community.
Okay. So it should be able to boil water now.
Okay.
And just move I just put this on the top of my desk. Just put a webcam on the top of my desk. It's kind of low resolution, but you should be able to see some smoke coming off the water.
Yeah, I can see it.
Okay, that's good.
Oh yeah, I can see the little bubbles. Yeah.
Yeah, I've had it work better. I guess it was just at a higher temperature then. It might have been at one of the hotter parts of the plate. I can also smell it. It's at 150, so It's not the best for the PCB, but I have 5 of these from JLC, so if one, I mean, as long as it doesn't like burst into flames, it's fine.
Yeah, definitely be careful. But this is really
yeah.
cool, and thanks for coming by to show us.
Okay, thank you.
All right, have a good night. All right, thank you everyone for coming by to show your projects. In about 5 minutes right here, PT and Lady Ada will be here for Ask an Engineer, so definitely stay tuned. And until next time, have a good night.